have you ever thought about the way that different parts of our body communicate? I think we often consider the body to be this one complete thing, this self, but really our body's composed of lots of parts. There are lots of organ systems, and each of those has organs, and all of those organs are made of tissues, and all of those tissues are made of cells. And it's crazy, but there are 100 trillion, or at least roughly 100 trillion cells in our body. So it's curious then, how do those 100 trillion different parts communicate? Well, one way is through the nervous system and through the prelate tracts of nerves, but not every part of the body is connected by nerves. I mean, how, for example, would part of the brain go about communicating with part of the kidney? Well, to talk about that, we're going to have to talk about the endocrine system. And the endocrine system is a system of organs that are called glands. And these glands secrete little chemical messages that are called hormones. And they release those little chemical messages called hormones into the bloodstream so that they can circulate from one part of the body to another part of the body in order to initiate an effect. And there are many parts of the body that use these hormones to communicate, but certain organs are really defined by this method of communication, and we call them endocrine glands. And so one of the major endocrine glands is the hypothalamus. And the hypothalamus is located right here. It's a member of the forebrain, and as a member of the brain, it receives a lot of those signals that we talked about from the nervous system. So those nerve signals are funneling into the brain, and the hypothalamus then, as a kind of dual member of the endocrine system, funnels those signals into the pituitary gland. And so because it plays that dual role between the endocrine system and the nervous system, it often gets taglined as the control center of the endocrine system. In addition to stimulating the pituitary gland, the hypothalamus actually makes some hormones itself also, and so it makes ADH and oxytocin. And ADH is antidiuretic hormone, and it's a main regulator of our fluid volume in our body. And then oxytocin is a hormone that stimulates the uterus to contract for females during pregnancy. And so that's the hypothalamus, member of the brain and member of the endocrine system, where it all begins, the control center. And then right below the hypothalamus is the pituitary gland. And the pituitary gland is located right here, dangling right below. And so the hypothalamus is about the size of a grape. And the pituitary gland is actually about the size of a green pea. But this little green pea is so important that it's called the master gland. And it's called the master gland because the pituitary gland takes that stimulation from the hypothalamus and it directs it to all of the other endocrine glands, or at least almost all of the other endocrine glands, such that their function is ultimately dependent on the pituitary gland to work well. And so that little green pea is a really important part of the endocrine system. And so one of the endocrine glands that the pituitary directs is the thyroid gland. And the thyroid gland is located right here in your neck. It wraps around your trachea. And your trachea is your windpipe, and so you can feel this thyroid gland on your neck as you swallow. If you hold your hands right around your Adam's apple and swallow, that meaty thing moving up and down, that's your thyroid gland. And one of its main jobs is regulating your body's metabolism. And it does that through the thyroid hormones T3 and T4. And another name for T3 is triiodothyronine, and another name for T4 is thyroxine. But the thyroid uses these hormones, the thyroid hormones, to stimulate the body's metabolism, which is crucial because that's how our body gets energy. And then right behind the thyroid gland are 4 spots known collectively as the parathyroid. And the main role of the parathyroid is regulating our body's blood calcium level. And the level of calcium in our blood is hugely important because calcium does a lot of stuff in our bodies. It's involved in muscle contraction, it's involved in bone growth, and all of those functions are really sensitive to the level of calcium that's floating around in our blood. And so the parathyroid glands, those 4 spots on the backside of our thyroid, regulate calcium through the hormone parathyroid hormone, or PTH. And then moving down the torso, we have the adrenal glands. And the adrenal glands are located right on top of the kidneys here. And they're called the adrenal glands because they're adjacent to, or right next to, the kidney system, which is called the renal system in medical speak. But we really need to further divide the adrenal glands into 2 parts, the outer part and the inner part. So the outer part is the cortex, and the inner part is the medulla. And the reason for the distinction is that the inside and the outside of the adrenal glands have 2 different functions. And so we'll start with the outside, or the cortex, and that's where the steroids, the adrenal corticosteroids, are made. And 2 major examples of steroids made in the adrenal cortex are cortisol and aldosterone. And cortisol is one of the body's stress hormones, so it functions to increase blood sugar in times of stress so we have energy. And it also has some anti-inflammatory functioning. And then aldosterone is one of the major regulating hormones of our body's blood volume and how much fluid is in our veins and arteries. And so that's the cortex. And then the medulla makes a class of hormones called catecholamines. And 2 major examples of catecholamines are epinephrine and norepinephrine. And I'm going to shorten those as epi and norepi. And sometimes epinephrine is called adrenaline, and that might be a little bit more familiar to you, but these catecholamines are really involved in our body's fight or flight response, that adrenaline response that we have to a stressful or scary situation. And so the medulla and the cortex make up the adrenal glands, but moving down the list and down the body, we have the gonads. And in females, those are the ovaries. And in males, the testes. And the gonads release the sex hormones. And so in males, the testes produce testosterone, and in females, the ovaries produce estrogen and progesterone. But these sex hormones are mainly involved in the development of our secondary sex characteristics like pubic hair and larger frames in males and breasts in women, but they're also involved in progressing us through those life stages that accompany those sex characteristics, like puberty and menopause. And then last but not least, we have the pancreas. And it's located right here in the upper part of the abdomen. And I saved the pancreas for last because it isn't involved as directly with the pituitary glands as the other endocrine hormones were, but it still uses those hormones to stimulate an effect in a different part of the body. And the effect that the pancreas stimulates is control over the blood sugar. And it does that through the hormones insulin and glucagon. And the pancreas is vitally important because without its hormones insulin and glucagon, we can't regulate how much sugar is in the body's blood versus the cells, and that can lead to major diseases like diabetes. And so with the pancreas, we can conclude our list of major endocrine glands. And so as we look at these glands and at these hormones, and we think about all of the different effects that are being stimulated in our body by them, it becomes pretty clear that there aren't just a few of these circulating in our bloodstream. There are literally loads of hormones circulating through our vasculature at any given moment. And so that poses a potential problem. If, say, that you're in the brain and you're trying to tell something to the kidney, you're trying to send them a message, and you put that in the bloodstream and you just float it down to them, how do you know that it's going to get there? I mean, isn't that what every other endocrine gland is trying to do? Well, it turns out that hormones are a lot like radio waves. In your city or in your town, there are many different radio stations, and there are many different songs being played at any given time by those radio stations. And even maybe from the next town over, there are radio waves filling the air of your town. But unless you're tuned in specifically to that station, you're not going to pick up on the song that's being transmitted. And in a very similar way, a hormone is not going to be received unless there's a very specific receptor on the target cell. And so the receptor and its location are very important in determining the hormone function. And we have classes that we use to help us identify which hormones fall into which function. And so the first class are autocrine hormones. And autocrine hormones function at the cell that makes them. An example of this is the T cell in the immune system. It actually secretes a hormone that it makes called an interleukin that signals the cell itself to increase its effectiveness in its immune function. And then another class of hormones are paracrine hormones. And paracrine hormones function regionally. And an example of that might be the hormones released by the hypothalamus that direct the pituitary gland. And then last but not least, kind of the classic class of hormones are the endocrine hormones. And these are the hormones that function at a distance. And an example of this might be the pituitary gland stimulating the gonads way far away. And so we have autocrine, paracrine, and endocrine classes that help us determine how a hormone functions. And so I know I just told you a whole lot about hormones, but this is your introduction into one of the most important ways that the 100 trillion little tiny individual parts of your body communicate.